Assalamu alaikum and very good day from Shahrajal. My name is Mohammad Muntasir Billah, and in these presentations, I'm going to discuss about game engine architectures. So basically, in the game engine architectures, I have assigned to two particular topic where I'm going to explore. I'm going to explain more detail in this topic where the runtime engine architectures, as well as I'm going to discuss about the tools and the asset pipelines. So basically the runtime architectures, where the first thing we're going to look through is the scenes graph. So scenes graph is limits the number of primitives submitted for renderings. Also is used for fresh terms calling to remove things outside of the visible screens, as well as is special subdivisions into BSP, quadtree, octree, or KD tree, and it is usually optimize the callings, that is occlusions and PPS. Those are into occlusions and PPS, also the DVD LUT systems. So is visual effects. So visual effects is basically used to particle systems, used in particle systems, decal system, light mappings, dynamic shadows. Also is full used to full screen post effects, and visual effects also define the manipulate the light mappings and dynamic shadows. Also, HDR lightings is also work for PRT lighting, subsharp, scatter, next particular decal systems. After that, post effects as well as environment mapping. Front end. So in the front end, usually have HUD menus, GUI for character manipulations, full motion video for cutscenes, and it's contain head-up display, full motion video, in-game cinematics, in-game GUI, in-game menus, also the adapt mode. Profiling and debugging. So in the profiling and debugging is usually code timing, usually work for code timing, display, allowed to display stats on the screens, debug, dumping performance stats, decode and playback game events, print statement outlook controls. So those are the effects usually debugged through the profile. Yeah. Then collision and physics. So basically the collisions indicate body dynamics, and the physics, which is physics engine. So basically creation is the own unique undertaking. So those are some many companies are use available libraries such as have physics, OG, Bullet. Yeah, those are companies use it in current. And there's the animations. So basically animation has five types of animations usually used for texture, body hierarchy, skeleton animations, part text animations, morphing. So, and the most popular animation is known as skeletal animations, which are usually work for input output layers, that is contain animation state, inverse kinematics, game-specific post-processing, LARP and adaptive blending, animation playback, sub-scripting animation, and animation descriptions. His ID. So his ID and audio. So his ID basically the keyboard and mouse abstractions. It's joypads, it's specialized controllers. So those are the his ID, human interface devices. And the audio is usually display fix. Those are often overloaded until the ends, and also the varies in sophistication based on needs. And many games are existing tools such as Exact and Schemes. So multiplayer network. So there has four main flavors of multiplayer networks, such as single screens, split screens multiplayer, network multiplayer, massive multiplayer online games. So single screens basically players on the same screens, and split screens multiplayer is usually perspective on the same screens. Network multiplayer, which are the network together. multiple compressed network work with together, and massive multiplayer online games, which is basically run in a central server. Gameplay foundation systems are basically most everything that makes the game a game, and also is wall loadings, real-time aging simulations, static wall elements, and is also known as hierarchical objects. Event systems. So event system object that need to communicate with one another. It's also easiest to handle those through a common systems, and it send the message that are routed to the event handler. Scripting systems, which allow for the creations on new game logic without recoupling, and also it speeds software development considerably. Artificial intelligence foundations, which are proprietary AI building blocks such as path plannings, nav mesh generations, object avoidance. Also, it has a middleware called gameware that provides many of those features. So game-specific subsystems, which is specific stuff needed for a game, and each layer could be considerable outside of the game engine itself, such as weapons, power-ups, vehicles, puzzles, and etc. So tools and asset pipeline. So tools and asset pipelines. So this is the architecture pipeline that usually use digital content creations in order to digital content creations. And usually you can see in the Maya and the DMax, they use this content. So then we have digital content creation. So as we see in the pipelines previously, so here we have a game engine deal with the data manifolds that has created on 3D meshes, textures, sound, animations, and also create using outside tools. Often create using outside tools. Using outside tools, those are Maya, 3D Max, Photoshop, and Sound Forge. Also there has the tools that of course those are tools of course need to be easy and also the reliables related to content creations. And also there is asset conditioning pipelines. So basically it's produce a variety of file formats that are not optimized for game, and it usually store the data in an easy to read and platform specific format. For example, conditioning assets. So conditioning assets, which are 3D model that must be properly tessellated, and branch geometry, which are convex hulls with samples, skeleton animation data, audio data, particular system data. So those are conditioning assets under the asset tools. Game world editors. So game world editors integrated into engines, and it allow game designer to work with the engines. For an example, using the real Unreal 8 Hammers and Radiant. Resource database. So need a way to store and manage the vast amounts of data. So in the reasons, for that reason, some companies use relational databases, which is MySQL or Oracles. And some companies use version control software such as Subversions, Purpose, or Git. And also there is some others use custom software, which is Notedog uses a custom GUI called Builder. And this is approach to two architectures where we have two categories, standalone and integrated. So standalone is another runtime engines, and integrated is runtime engines as well as tools and world builders. Web-based tools. So web-based tools basically there has various uses. The first uses you can see asset management. So there is asset management. For the asset management, we use the web-based tools. For the schedulings, we use web-based tools. Bug management. Also, the easier to build, usually easier to build than standalone applications. Also, it's easier to update without forcing ARN installs. if it just need to present tabular data and have forms use a web interface. Yeah, that's all. That's pretty much it about the runtime architectures as well as the asset tools. There's tools and asset pipelines. Yeah, that's it from me. Thank you.